All right, good morning. Today we are going to continue talking about exponents. So we are going to go over some of the properties of exponents, which means we're going to be looking at the generalization of the laws of exponents. So this is going to be called lesson 1.4. And this is day 2 of this lesson. So we started this lesson yesterday. Today's the second day. With this being the second day, we're going to be wrapping it up today. So you're going to get homework problems that relate to this lesson as opposed to just stuff that went along with what the video is doing. So the properties that we want to talk about, there's 5 that we are going to list. The first one is called the product of powers property. The product of powers property would say if we had some base and it was to some exponent, if we took the product, so it's got to be the same base, to a different exponent, we would take those two exponents, and the way we would combine them is by adding. So this is the product of powers property. The second property that we are going to talk about is the quotient. So the quotient of powers property. The quotient of powers property, I think there's an S there, would say if we had 2 of the same base being divided, so some a divided by some a, and one is to the m and one is to the nth, we would take and combine those by subtracting. So this is fine, this will work every time, but you might end up with a negative exponent. So that's the only hang up that I have about this one. My suggestion would be choose whichever exponent is larger and subtract from either the top or the bottom. So you want your number to be positive. So if it's bigger on the bottom, you would subtract n minus m and leave it on the bottom of the fraction, and there'd be a 1 on the top. So that would be my suggestion. But you can definitely do this. This works every time. The third one is called power of a power. So power of a power property. So this means we have like x squared to the 3rd power. So how we would deal with that. So say we have a base m and a and it is to the mth power, and then that's to the nth power. We would combine those just by multiplying. So we'd have m times n. The 4th property is power of a product. Power of a product property. And this property would say if I had 2 bases, so a times b being multiplied, and that quantity was to the mth power, I could simplify it by distributing the m. So by distributing my exponent, and I'd have a to the m times b to the m. The 5th property that we are going to list is power of a quotient property. Power of a quotient property. Power of a quotient property would say if we had some fraction, a divided by b to the m power. My bad. So if we had something like this, a divided by b to the m power, so that whole quantity is to the m power, you could take just like we did up here and distribute to each value. You distribute that exponent to the top and to the bottom. So we'd have a to the m over b to the m. Okay, so there's 5 different properties. Now we are going to do some problems that involve using all 5 of these properties. So if you look at example 4 on page 30, we have A, B, C, D that we are going to go over together. So A is negative 1.5 y. So negative 1.5 times y, and that whole quantity is squared. So now we're going to be using this power of a product property where we distribute the squared to each term inside of the parentheses. So we'd have negative 1.5 squared times y squared. So you could simplify negative 1.5 squared to get positive 2.25, right? A negative times a negative is a positive, and then 1.5 squared is 2.25, and then y squared. So then that would be our answer. That's the most simplified we could get that. B, we have A divided by negative 10, and that is cubed. So from here, we would use the power of a quotient property where we're distributing that 3 to the A and then to the negative 10. So we could get A cubed over negative 10. Make sure, because it's a negative number, make sure you keep it in parentheses. And then from there, you could further simplify by actually cubing that negative 10. So you could get an answer of A cubed over, it'd be negative, a negative times a negative times a negative ends up being positive. Oh, wow. A negative times a negative is positive, and then times another negative is negative. So that would be 1,000. But if you wrote that answer, that'd be fine. So either one of those. I'll put an or there. For C, we have the quantity of 3D divided by 2, and that quantity is to the 4th power. So now we are going to be using this power of a quotient property where we distribute to the top term of the fraction. So we distributed to the top and to the bottom. But now not only did we distribute to the top, we have 2 terms on the top. So now we need to use that product property. So this one here, where we distribute the 4 to the 3 and then to the D. So we have 3 to the 4th, D to the 4th, over 2 to the 4th. You could also do this from the beginning. This is just an extra step. You could have said, I know that these are 2 separate terms, so 3 to the 4th, D to the 4th, over 2 to the 4th. From here, you can multiply this out, so you could actually find 3 to the 4th and 2 to the 4th, but you don't necessarily have to. This is a perfectly good answer. For part D, we have the quantity of 2x over 3, and that is to the negative 5th power. So from here, just like I told you over here, you could distribute from the very beginning. You could do that same thing. So we could have 2 to the negative 5th over 2 to the negative 5th, x to the negative 5th, over 3 to the negative 5th. So now we have lots of negative exponents that we have to consider. Something that I would like to do is start by simplifying the negative sign. I know that to get rid of this negative sign, I take the reciprocal of whatever it's attached to. So it's attached to this whole fraction. So if I start by taking the reciprocal, I end up with this thing where I don't have negative exponents, which is nice. So the reciprocal would be 3 over 2x, and now it's just to the 5th power. So from here, I can distribute that 5. So 3 to the 5th over 2 to the 5th, x to the 5th should be our answer. So we were asked to do this using only positive exponents, so that's why I made sure to flip it around. So there's some problems on page 30, problems 11, 12, 13, and 14. I'm going to write them down really quickly for you, but after that, I do want you to pause the video and try. So number 11 is the quantity of 10y to the negative 3rd. Number 12 is the quantity of negative 4 over n to the 5th. Number 13 is the quantity of 1 over 2k squared to the 5th power. And then 14 is going to be the quantity of 6c over 7 to the negative squared. So there they are. Go ahead and try these. Pause the video. So you should have gotten for this one the negative 3 when you square it in. We would get 10 to the negative third, or you could simplify by taking the reciprocal right away. So 1 over 10 y to the third, which would be 1 over 10 cubed y cubed. For number 12, we would go ahead and just distribute this 5 in. So leave the negative out in front. The reason that we'd leave the negative is because this is an odd exponent. Otherwise, I might suggest attaching it to the 4 and putting it in parentheses. So you could say negative 4 in parentheses over 5 n over 5. So either one of those. For 13, go ahead and distribute that 5 in. So we'd have 1 to the 5th over 2 to the 5th k. And now we have this where we have to multiply. So the powers of a product, powers of a power, sorry. So k squared, 5 squared. Whoa, k squared to the 5th power. I'm sorry, I probably shouldn't be making a video today. I feel really tired. So we would multiply the 2 and the 5 to get a 10. And you can simplify this. You don't have to write 1 to the 5th power. So 1 over 2 to the 5th, k to the 10th. For 14, now we have a negative exponent, so we need to start by taking the reciprocal. So 7 over 6c, and now that whole thing is squared. So we end up with 7 squared over 6 squared c squared. And that's what I would say the answer is. So there's one more example that I want to look at with you guys. This is a real world problem, and this does come up where we have to simplify equations. I know we went over it in Math 1 last year, but it got kind of confusing. So this is example 5 on page 31. Example 5 on page 31. So we're given this image of a cylinder. It's laying on its side like this. It's got that labeled as h. The radius is labeled as h divided by 2. When I look at cylinders, I prefer to draw them this way. I feel like it's easier for me to label stuff when it's drawn that way. I had a really big base. So anyways, the radius is h divided by 2, and the height is just h. So they want us in this video to find the volume of the cylinder using these two pieces of information. If we are given the formula for a cylinder, formula for volume of a cylinder, V equals pi r squared times h. So in this case, r squared is going to be h over 2. So now we need to substitute r squared, r, so that's our r value. So we'd end up with pi times h over 2 squared times h. Start by simplifying the parentheses. So pi h squared over 2 squared times h. And now you know that when you have h's next to each other, you could combine their exponents. So that's really like h to the 1. So that would end up being pi over, if we were to add those, h cubed, and then you could simplify that as 2 squared is just 4. So this is an answer, or you could write it as pi h cubed over 4. Either one. Not both, but one of them. All right, so then your homework that goes with this is going to be on page 32, and we are going to do numbers. Pay attention to the numbers. So 5 through 21, odd. That means 5, 7, 9, 11, blah, blah, blah. And then I want you to do problem 26 and problem 29. So I want you to try those problems.